Good afternoon or morning, depending upon where you're located. I'd like to take a few minutes to thank you for taking time out of your schedule to attend this webinar. We're pleased to introduce our latest member of our CombiFlash family, the CombiFlash EasyPrep system. And first question, I think, is what is a CombiFlash EasyPrep? Well, the answer is it's a chromatography system that's capable of running flash and high performance or prep purifications. Flow rate range is from 1 to 200 mils per minute on both the flash and the prep side. It has the ability to run up to 200 psi on flash, as all of the other CombiFlash products have. And on the prep side, it can run up to 3,500 psi. And like all of our other products, it has the choice of UV, UV-Vis, ELSD, and mass spec detectors. I think the other thing that's really important is the ease with which you can switch between flash and prep, and I'll demonstrate that here in just a couple of minutes. Question that we first asked when we started developing this project is, why a CombiFlash EasyPrep system? What we found from talking to a variety of users was that flash gives adequate separations for researchers 80-some% of the time, but about 20% of the time preparative HPLC is needed for the more difficult separations, or traditionally used to purify final product prior to submission for testing. Typically, preparative HPLC requires a skilled chromatographer to operate, and some of that's because of the design of the software that's used in traditional preparative HPLC systems. EasyPrep is a system that provides simple operation using peak track software, which is what's used on all of our other flash systems. And it's a very simple user interface driven by touchscreen. The other thing is why the CombiFlash EasyPrep system might be popular is because of the faster turnaround time that you can get from a centralized service labs. And the last thing is it takes up minimal hood space. It's slightly larger than our current CombiFlash RF Plus system, and so therefore it doesn't require an enormous amount of space that's very valuable in the laboratory today. Some of the key features, one is the pumps. They're a high pressure HPLC type pump, and as we mentioned earlier, during prep operation you can get up to 3,500 psi at up to 150 mils per minute, and then it gradually decreases down to 2,500 psi at 200 mils per minute. The other feature is that it's auto priming. Some preparative HPLC pumps, they have to be manually primed. That's not the case with the EasyPrep system. The other thing is that on the high pressure injection side, it's done via a liquid injection using a loop that's electrically actuated. And the loop size can be varied. The standard loop is a 5 milliliter loop, but those can be varied in size from 1 to 10 mils, depending upon the volume and the number of grams of sample that you're planning on injecting onto the preparative HPLC column. The third key function that we have is that there's a flash prep selection valve electrically actuated, and it automatically switches flow paths as the user moves between the flash and preparative HPLC modes. Well, it kind of got its name of EasyPrep from the fact that it's very easy to switch from flash to prep. As an example, it's just 2 clicks to go from a flash operation to the high pressure side. And it's even simpler when you go back from prep to flash. You simply install a ReadySep RF or ReadySep RF Gold flash column on the flash side, and the system automatically recognizes that and flips back to the flash mode. To make it simple for the user to see which mode they're operating in, we've color-coded the screens so that it's easily seen which mode is active. So if the screen is blue, the system is operating in the flash mode with 200 psi maximum. If it's green, it's operating in the preparative mode with 3,500 psi as the maximum pressure. When I say switching is easy, this is an example. This is the standard screen that comes up at the beginning of the run when you power the system on. Simply click on this down arrow here on the ReadySep menu and select Prep HPLC column off of the drop-down that will pop up. Next step is to simply press play, and you'll see that the screen has gone from blue to green. And you can see here that under the ReadySep, we now show that it's a C18, in this case a 50 by 150 millimeter column that's been activated. If that's not the preparative column that you want to use, changing preparative columns and the conditions associated with those is easy. Also, see the prep column is aligned, is displayed down here. Simply press the down arrow. A drop down pops up which shows you the HPLC columns that have been built previously in a prep column list. You can select the column of choice from this list and simply press play to start the run. Likewise, if you just entered into this area by mistake, you simply select flash column. Screen will go back to blue and you'll be back on the original screen where you can be operating in the flash mode. Since the preparative system runs in liquid load only and uses a loop injection, there's two choices that are offered when running in prep injection. One is where we do load now, and so if that's the mode you want to run in, you simply load your sample into the loop and press sample loaded, and the system will start automatically to do the purification. The other mode is load after equilibration. In this mode, you can start the equilibration, and then during the equilibration process, you can actually load your loop, and the system will wait for you to inject. Those steps are really highlighted on this slide. Here you see load sample loop with sample and inject now. Press the sample loaded button. The system then starts the equilibration, and once the equilibration is completed, the injection valve moves from load to inject mode, and your purification begins. On the second option is inject after equilibration. You simply press the start equilibration button on the screen. Once the equilibration is completed, the system will wait for the sample to be loaded. The user loads the sample and presses the OK on the message that's displayed on the screen. And again, the valve switches from load to inject mode, and the purification begins. One advantage I personally like, I like the inject after equilibration. One thing it does, equilibration is equilibrating the preparative HPLC column for initial conditions, which takes a few minutes, and that allows me to start the equilibration and then make up my final sample solution, filter that solution before I load it into the valve, and then once I have the sample prepared, load the valve. If I get drawn away from the instrument for a while, once it finishes the equilibration, the pumps stop and it sets waiting for the user to come back and load the loop and press the OK before the pumps resume operation. So there's no additional solvent loss, but it does allow you to prepare your sample while the equilibration is in process. Since many customers will be running the system in a mode where on the flash side they'll be running normal phase, something like hexane ethyl acetate, and on the prep side we'll be running in a reversed phase mode where you're running maybe a water methanol gradient. We've automated that phase change operation. And this is something that's set up in the configuration screen on the system on initial installation. There are some rules that must be followed, and those rules are shown in this window. Solvent 1 must always be your weak normal phase solvent. Solvent 2 must be your strong normal phase solvent. Solvent 3 must be your weak reversed phase solvent, and solvent 4 your strong reversed phase solvent. Once you have your solvents in those positions, and you can see up above here on this screen, we've got hexane ethyl acetate in 1 and 2, and 3 and 4 is water and methanol. Once those are established and I've enabled the automatic phase change, then the system will prime the solvents in an order so that to ensure miscibility every time you change from using solvent 1 and 2 to using solvents 3 and 4, or vice versa. If you are doing a reverse phase prep run and you want to go back to flash, you simply put your flash column in, the system reverts to flash, the system recognizes that you're now going to be using solvents 1 and 2, and so it will automatically go through a phase change operation to flush the lines, and you can now start to use your normal phase solvents. If you're familiar with the operation of the CombiFlash RF Plus or RF200 line, you're familiar with using our manual control screen. We made some changes in manual control for the Easy Prep. One major change we have here is we have a flow diagram which shows you the flow path of the solvents for the method or mode that you've selected up above here. So in this case, I've selected that the flow path is going to be through the prep HPLC loop and column. And so you'll see here it comes down through from the pump to the flash prep selection valve, over to the prep injection valve, through the loop, through the column, and then back through the flow cell and to waste. This allows us to wash the flow cell, and just about every flow path that we have, except for one, washes the flow cell. And it also, so if your flow cell becomes dirty, it can be flushed with any of the solvents that are displayed here. So you can choose between water methanol or hexane ethyl acetate, or whatever solvent you have in positions in one of the 4 positions. Customers that use our current flash systems have asked for this, which is a maximum volume. Let's say I want to finish a run, and after I finish that run, I want to set my prep HPLC column up and I want to store it. I program in what percent B in this case, so maybe 75% B, and then I tell it how many milliliters, maximum mils of solvent that I want to pump through this column to do the wash, and then I simply pump this percent B, and this 50% here changes based upon what's displayed in this window. Likewise, if I want to flush the column with 100% methanol, I can simply press pump solvent B and it pumps the 100%. But in this case, the system will pump the solvent at whatever flow rate I've defined until it reaches 1,000 milliliters or 1 liter, and then the system will stop pumping. So, excellent way for me to after I'm through with my column, to go in, set it up, flush my column. I can flush my column without the loop, or I can flush it with the loop in the flow path, user defined. And once it's done, the system will shut off automatically, so I don't have to stand and wait. Once you're finished with this, simply click close manual control, and you're back to the initial ready run screen. I mentioned that there's several options, and this is just a list of the options. We're not going to go through these today, but you can see here's Prep HPLC column, and this is the one that I showed you. Every time you select one of these, you'll get a different diagram which shows you the flow path, so you'll know whether you're cleaning your flow cell or whether it's bypassing the flow cell, and like prime to waste does not go through the flow cell. It's simply used in when you're priming the system. We have the auto prime mode, and that can be activated also through manual control. If you're familiar at all with the flash columns, you might be aware, some customers aren't aware, but if you stick a flash column into our system and it reads the RFID tag, you can go into Method Editor and push this button called Column Data. And what it will do is it'll show you on the ReadySep column that you put in place, it'll show you the last solvent that was used, the number of runs on it, and it'll also give you the lot number for the column. That's all that information is stored on the RFID tag that's associated with the column. Now, normally, if you're doing normal phase flash, you normally don't see that because those are intended to be single-use columns, and if they left with the organic solvents in over time, the body of the column swells, which causes a bed to collapse, and so you probably won't have experienced this. However, if you use our reverse phase flash columns, that information is very useful so that you know how many runs you've made on it and what the last solvent was used. Same type of information can be picked up from the prep column. We store the history, and so by pushing the column data button, you can see here that it tells me what the prep HPLC column is, the number of times it's been used, what the last fluid was, and when it was used first and last times. Now, unlike the flash side, where that information is stored on the RFID of the flash column, we don't have an RFID tag on our preparative columns, and so that information is actually stored in the system itself. So I guess the caveat is, as long as you're using a prep column on the same Easy Prep system, then the information will be accurate. On the other hand, if you take this C18 20 by 200 column off of this Easy Prep system and you take it and run it on some other system in the lab and you bring it back, you won't have that information of what the number of runs you did while it was missing from the unit, nor will it know what the final solvent was. It'll come back. If you put it back in and you click this column data button, it'll come up with whatever was in it the last time you used it on this specific Easy Prep system. Just a few slides on operation. Talked about earlier I showed you the preparative column list. Well, this is something that has to be done the first time you set the column up, the system up, is that you have to build a prep column list. And this can be as long a list or as short a list as you want. To do this, you simply press New on the, and this is in the configuration screen again, where in Instrument Configurations, where you got a choice to enable the auto phase change. There's a tab for Preparative HPLC, and on that tab, You'll see it's a green screen, whereas the other screens are blue. Again, this is just to indicate that you are working on the high pressure side of the system, or you will be after you've built this. You select new and you give it a column name. The column name here is really anything that you want to call the column. It's only used for identifying the column. So if you want to call it Ron's column or Bill's column, you can do that. That way, when you select the column off of the list over on the run screen that we showed you earlier, it'll have some meaning to you. Too many times, there's probably everyone's got 2 or 3 C18 columns that may have the same dimensions, but they're not really the same column, and so this is a way to distinguish those columns. You then select the particle size, the diameter. When you select the diameter, that determines the flow rate that the system will recommend you to run at. And then you define the length of the column. And the length of the column combined with the diameter of the column calculates what the column volume of the column that you're installing will be, and then that determines your equilibration time and the suggested gradient conditions. So once you put those in, the system will automatically create a recommended C18 column. And if you want to just accept whatever it recommended, you simply press the Save button, and it will save that information. So every time you activate this column over on the run screen, it'll load the predefined method. Now, on the other hand, if you want to redefine the method, you simply click on this Define Method button. And what happens then is it opens up essentially a method editor screen that's commonly used for your Flash columns. But in this case, this method editor is building a default method to be used with the column that you've identified. And so you can select your peak collection, whether you want all peaks or none. You can program in here what wavelength you want to detect at, as well as what detectors you want to have turned on. You'll see here that this flow rate is based upon the calculated volume, or the diameter, and so this is a 30 millimeter column. And then the equilibration volume, it takes and figures 5 times the column volume, or sorry, 3 times the column volume to determine what the equilibration volume is. Likewise, the run length is a function of flow rate and column volume, and that defines this gradient length here. That's, I believe, essentially 6 column volumes from initial conditions to your maximum conditions. And then there's a column volume held at 100% methanol in this case, and then it drops back down to 50% in case you want to store the column and not make a secondary run. All of these things can be changed, so you can shorten the run length, you can shorten the equilibration volume, lower the equilibration volume, anything that you want. And when you exit this, it asks if you want to save this method. Once you say yes to that, anytime you activate the column that's associated with this method, then it will load those conditions. I want to back up one slide here. The other thing is the default column setting here. What the default column is if you've got a column that you use primarily, let's say 70–80% of the time on this Easy Prep system, you want to set that as a default column. And if you click this down arrow here, you'll get a listing of all the columns that have been predefined. And you pick the one that you're going to use most frequently, and you set that for the default column. And then on the Ready screen, if you'll remember, when you went from the Flash startup screen and you selected HPLC column, it automatically loads this default column as the column that you're going to use. And then there was another screen that I showed you where you could push the Ready Set button a second time, and you could select a different column. The other thing that I think is useful in this screen is, let's say this C18 50 by 150 column is the column that you're going to use, but you use it for different analysis. And so let's say you're going to run benzodiazepine purification on it one time, and it has that has certain run conditions versus maybe antioxidants at another time, which has a second set of conditions. If you say your column name would be benzodiazepines, 50 by 150, and then have a method, find a method associated with that, and then you took the same column, only this time you called it antioxidants 50 by 150, and you could define a method with different conditions, so therefore you could use the same column and just pull up different conditions based upon which column you selected on the run screen. So anyway, I think that's a really useful option that you have, where you can use one column, but if you use it for a variety of different purifications with different conditions, you can predefine those and give them a column name that has some meaning. To go along with the CombiFlash Easy Prep system, we're also introducing a line of what we call Ready Set Prep columns. The thing is to keep in mind with these, the bonding on the Ready Set Prep column, it uses the same bonding and same spherical particles that are used in our Ready Set RF Gold columns. So transitioning from a reverse phase prep flash method to a reverse phase prep method is a fairly simple task, because the selectivity of the C18 column, for example, would be the same in both the flash and the prep modes. Another thing that we've added to our offering is an analytical column that is not compatible with the Easy Prep system, but it is primarily for use on any lab analytical HPLC system that you might have to do method development. So instead of TLC, you might use this analytical column to develop your gradient conditions on your HPLC system, and then transfer those over to the corresponding preparative column, or even to the flash column that was a reverse phase. All of our prep columns are 5 micron spherical media. They come in the same bonding as the Ready Set RF Gold columns, C18, C18AQ, a wide pore material, which is a C4 300 angstrom, and silica. We offer guard columns that in the same medias that are 20 by 30. Again, they're packed with 5 micron spherical material. And you can see over here the diameters that we offer. The 4.6 is only offered in a 150 millimeter length, but there's a 10 millimeter up through 50 millimeter internal diameter columns available, and most of those columns in it are available in both 150 and 250 millimeter lengths. So you have a choice of 4 different medias and 4 different diameters on the preparative side, and 2 different lengths to choose from. So wide variety. Just wanted to show you some typical prep results. This is a column, a customer sample that we ran that was run on a 20 millimeter by 250 millimeter C18 ReadySep prep column. And you can see the peak shape. This is fairly sharp peaks, very nicely separated series of impurities that were cut out during the collection process. And so results look just like our flash results, if you're familiar with our CombiFlash RF Plus systems. And again, all of the same thing about zooming in, reformatting the graph, adding UV or mass spectral data if the system happens to be interfaced with pure ion mass spec. Just one word on some sample loading guidelines. Typically on the flash side, we say we can run from about 4 milligrams up to about 33 milligrams when you're using a 330 gram ReadySep column. So here you can see that if you want to purify 7 to 70 milligrams, typically that's done on a 10 millimeter column, up to 300 milligrams on a 20 millimeter column, and so forth, 30. You can see the various flow rate ranges. You could run a 75 millimeter column on our easy prep system, but you would be operating probably at the low end of the recommended flow rate range. And you can see here that there's a little note that says that these flow rates are general guidelines. Obviously, columns with the 5 micron material will run will maximize out pressure-wise at the lower half of these flow rate range. But during our testing, we were just running, last week we were running a 50 by 150 ReadySep prep column at 118 mils per minute, generated about 2,000 psi of back pressure. So just as a summary, just want to go over the RF Plus family in case you're not familiar with our other flash products. There's the 150, the Plus, which is UV or UV-Vis, the RF Plus Lumen, which has integrated ELSD, the CombiFlash RF Plus Pure Ion, which is a mass spec, the Torrent, which is shown over here for scale-up operations where run columns up to 3 kilos in size. We have ReadySep RF and ReadySep RF Gold columns in the flash side, 3 different fraction collectors, and of course a standalone ELSD for operation with the Torrent. I should mention, and I don't have it on a slide here, but the Easy Prep system comes with UV-Vis. You can integrate in an ELSD, just like in the Lumen system. You can interface it with the Pure Ion mass spectra system. So you have a full offering of columns options or detector options on the Easy Prep system. And last thing, all of our systems are compatible with iPod Touch, iPhone, iPad, or a desktop Explorer, excuse me, and desktop software such as Internet Explorer or Firefox. Last thing, thank you for your time. My contact information is on this slide. I want to remind everyone we do have this free book, which is Guideline and Tactics for Flash Chromatography. If you go to isco.com/flash guide, you can do one or two things there. You can download a PDF or if you put in your contact and shipping information, we can send you a hard copy. It's an excellent book for people that aren't familiar with flash chromatography. It has a lot of information for even people that are used to flash chromatography. However, maybe they want to change different solvents and change their selectivity on the flash side. There's some good charts in there that talk about solvent selectivity. So, and then there's we'll be doing webinars this year, roughly one a month throughout the year. And so this is just a listing of some of the other topics that we've covered in the past, or we will be covering again as we go through the coming months. Thank you for your time. I'd hope to keep this under 30 minutes, but that never seems to work. But I think we've got some questions. I think there's a little chat box in your screen. If you've typed in the questions there, I'll try to answer those. And so let's see if we've got some questions. Okay, one of the questions we have is, what is the column diameter range? We're really expecting typical column ranges to be between 10 millimeter and 50 millimeter. Those are the normal columns that we've found that are very popular in the industry. I know one slide it shows that the flow rate of the system is down to 1 milliliter per minute. So you might ask why I said that the 4.6 millimeter analytical column wasn't compatible with the Easy Prep system. There's essentially the answer to that is one, you can program it down to 1 mil per minute. Not its best flow rate. Typically 5 mils per minute is really and up is the operating range of the system. But the real thing is there's a significant enough of delay volume in the mixer and the tubing that analytical to do a gradient run is not really practical. Okay, another question was about what's the smallest particle size. As I mentioned, our preparative HPLC columns run down or 5 micron in size. That's kind of the smallest particle that's used in preparative HPLC columns. Obviously, you can use larger particles. I know that there are some preparative HPLC columns that are made with 10 micron, 15 micron, and 20 micron. But 5 micron particles in today's technology is a very stable particle. So it's a very rugged particle, and it does give us your most efficient separation that's really available in column technology today. Someone asked about how many grams can be purified on flash columns. I mentioned that a little bit a few minutes ago, but typically up to 33 grams on our 330 gram columns, and it really depends upon how good a separation there is. If your impurities are close eluting, maybe that amount of material or less. If the impurity is widely separated from the target compound, you can certainly load more. So it really depends upon how closely eluting the impurities are and how well separated they are in the mobile phase you've selected. Let's see. Okay, there was one about the RFID on the prep columns. That is something that is not there. But as I mentioned, the system does track internally in the Easy Prep system itself what solvent was run and how many times it's been run. what the last solvent was and when the last run was. But there is no RFID. To be quite frank about it, there are a lot of columns on the market for preparative chromatography. Ours will be just one of those. So we didn't feel that it was to the end user's advantage for us to add the RFID capability on the preparative side of the system. Let's see, I see a note here, a question here that says if I use hexane, ethyl acetate, water, acetonitrile for the 4 solvents, when I switch from reverse phase to normal, does it use acetonitrile to flush the system? Other similar systems use IPA to flush. You use methanol water as an example. Did you really use it to test the system? I do not see people reporting methanol as the strong solvent for reverse phase. Some people use, there's a lot of people who use methanol, a lot of people use acetonitrile. Methanol is often used in reverse phase as your stronger solvent, simply because it's less expensive than acetonitrile. Personally, my experience shows that acetonitrile tends to produce sharper peaks, less tailing than methanol does when you're using it in reverse phase mode. You can run the system. You can use isopropyl to flush the system out if you want. What if when you switch on our system and you've activated the automated phase change, what happens is the first thing it does is it flushes the system with acetonitrile. It'll then flush the system with ethyl acetate, and the last thing it'll do is flush the system with hexane. That way, that gives you the miscibility is not an issue as you go from acetonitrile to ethyl acetate to hexane, or if you go from methanol to ethyl acetate to hexane, there's no immiscibility issues that crop up. So we do have what we call a manual phase change mode, and in manual phase change mode, it asks you to it's a menu-driven option, and so where it asks you to take the lines out of the original solvent, so you want to change solvents on, place them in a vessel with isopropyl alcohol in it, press the next button on the screen, and it flushes the lines with isopropyl alcohol, and then you take then it prompts you again to take the lines and place them in the final solvents that you want, and again it'll flush the isopropyl alcohol out with the two new solvents that you've selected. So that's one way, but during some of our beta testing, we found that a lot of customers didn't want to remove their lines and go through the isopropyl alcohol step. So that's when we came up with the automated phase change procedure. And someone asked about what is the footprint. I can tell you that the system is 27 inches high. If you're a current RF Plus user, that's just a little over 2 inches higher than an RF Plus. The width of it is, well, the width and depth is 17 inches by 17 inches. The depth is exactly the same as an RF Plus, and the width at 17 inches is just a little over 2 inches wider than an RF Plus. So it's still a very small footprint, so it minimizes the amount of hood space that's taken up. Are there any other questions? Doesn't look like it. Again, thank you everyone for attending. I hope the rest of your day is a pleasant one, and we certainly appreciate you taking time out of your schedule.